What if I told you that gravity, the force that keeps your feet on the ground, makes planets orbit stars, and even shapes the entire universe, might not be a force at all? For centuries, we believed gravity was an invisible pull between objects. But what if it's something far more mysterious, a bending of reality itself? This is the story of how two of humanity's greatest minds, Isaac Newton and Albert Einstein, unlocked the invisible threads that bind the cosmos together. Get ready, because what you're about to learn will change the way you see everything, even space and time. Our journey begins with Sir Isaac Newton, the man who first defined gravity. In the 17th century, Newton looked up at the moon and wondered, why doesn't it fall to Earth? His answer changed science forever. He realized that everything in the universe with mass attracts everything else. Whether it's an apple falling from a tree or the moon orbiting our planet, every object is pulling on every other object through this invisible connection called gravity. Newton's law was beautifully simple. The greater an object's mass, the stronger its gravitational pull. And the farther two objects are apart, the weaker that pull becomes, decreasing with the square of the distance. That means if you double the distance, the gravitational force drops to just 1/4, triple it, and it becomes 1/9. With this single equation, Newton explained how the planets dance around the sun, how the moon moves around Earth, and even how the tides rise and fall. For over 200 years, his theory ruled physics. It worked so perfectly that people began to see the universe as a giant clock, predictable, precise, mechanical. But one question haunted scientists: how? If the sun is 150 million kilometers away, how does it pull Earth without touching it? No strings, no contact, just empty space. How could a force act across such a vast void? That mystery lingered, until one man dared to see the universe in a completely different way. That man was Albert Einstein. Einstein proposed something radical. What if gravity isn't a force at all? To most scientists, that idea sounded insane. But Einstein believed that what we call gravity is simply the result of space and time themselves being curved. Imagine the universe as a giant, invisible fabric, a cosmic sheet stretching in every direction. When something massive, like the sun, sits on that sheet, it bends the fabric. Now, if you place a smaller object, like Earth, nearby, it will start rolling toward the sun, not because the sun is pulling it, but because space itself is curved around it. It's not a force dragging planets through space, it's the shape of space guiding their motion. To visualize this, picture a heavy bowling ball placed in the middle of a trampoline. The fabric dips under its weight. Now roll a marble across the surface. The marble will start circling the heavy ball, caught in the curve. That's exactly how the planets orbit stars, not because they're being pulled, but because they're following the natural curves of space-time. Einstein described this relationship in a single poetic sentence. Mass tells space-time how to curve, and space-time tells mass how to move. But how did he realize this? Not in a laboratory, but in his mind. One day, while sitting in his office, Einstein noticed a man cleaning windows high above the ground. He suddenly wondered, what would that man feel if he fell? In that instant, Einstein imagined something profound. A falling person wouldn't feel gravity at all. He would feel weightless, just like an astronaut floating in space. Einstein called it the happiest thought of my life. He realized that free fall on Earth and floating in space are exactly the same thing. Gravity and acceleration are indistinguishable. This insight became the heart of his general theory of relativity. Let's imagine his famous thought experiment. You're inside an elevator floating in space. A ball floats next to you. Now, if your elevator begins to accelerate upward at 9.8 meters per second squared, the same acceleration as gravity on Earth, the ball will appear to fall to the floor. Even though you're in deep space, you'll feel the same weight as standing on Earth. Einstein concluded that acceleration and gravity are two sides of the same coin. Next, he wondered, could light, something with no mass, also be affected by this bending of space-time? According to Newton, no. But Einstein predicted that even light must follow the curves of space. That means when light passes near a massive object, like the sun, its path should bend ever so slightly. At the time, this was unthinkable. Light was supposed to move in a straight line, forever and always. But Einstein's math was clear: gravity bends space, and space bends light. In 1919, 4 years after Einstein published his theory, British astronomer Sir Arthur Eddington set out to test it. During a total solar eclipse, when the sun's brightness was blocked, he photographed stars near the sun's edge. And what he found shocked the world. The star's light had shifted, bent exactly as Einstein predicted. In that moment, Newton's universe of invisible forces gave way to Einstein's universe of curved spacetime. Gravity wasn't a mysterious pull, it was geometry. Space itself was alive, flexible, dynamic. Imagine shooting a beam of light across the universe. You think it's moving straight, but from the outside, its path curves around massive stars and galaxies. The shortest distance between 2 points isn't always a straight line. In curved spacetime, it can be a loop, a curve, even a spiral. Einstein's vision changed everything, from how we understand planets and stars to how GPS satellites work today. Time itself slows down near massive objects. The closer you get to strong gravity, the slower time ticks. Your watch on Earth runs a little slower than a satellite's watch in orbit, and we've measured this difference exactly as Einstein predicted. Space and time aren't separate, they are woven together into a single, living fabric called spacetime. When mass appears, it doesn't just bend space, it warps time itself. This is the beauty of Einstein's genius. He didn't just redefine gravity, he redefined reality. So now, when you drop a ball, it isn't being pulled down by some invisible hand. It's simply following the curve of the spacetime beneath your feet, a path carved by Earth's mass. Newton showed us how gravity works. Einstein showed us why. Together, they revealed a universe far stranger and more beautiful than anyone could have imagined, a universe where space bends, time flows differently, and light itself dances on the fabric of creation. And even today, a century later, we're still testing Einstein's equations, in black holes, in gravitational waves, and across billions of light years. Every time, the universe whispers the same truth. He was right. Because in the end, gravity isn't just a force. It's the shape of reality itself. It's the cosmic story written into every atom, every star, and every heartbeat of time.